Okay. In this video, we're going to talk about polynomials and how to add and subtract polynomials. So let's review what a polynomial is. So let's say you have a real number x, and n is a positive integer. Okay. Then this symbol x to the n, okay, what that means is x times itself n times. So you take n x's and then multiply them, and that is called x raised to the nth power. And the x is called the base, and the n is called the exponent. So those are numbers. The base is a number, okay? It's the number that is being multiplied, and n, the exponent, is the number of times the number of x's that are being multiplied. Okay. So when you have something like this, it's an example of something called a monomial. So a monomial is a number, a variable, or a product of a number and powers of one or more variables. Okay, there's a lot of terminology, but we'll do some examples of this. So the numerical part of a monomial is called the coefficient, and the degree of a non-zero monomial is the sum of the powers of the variables. The powers being the exponents. And 0 is a monomial, and by definition it has no degree. There's a reason why we define the degree of 0 to be undefined, so it doesn't have a degree. But if you have a constant, then it has degree 0. So non-zero constants, those are monomials. These have degree 0. Let's look at some examples. So 17x squared is a monomial because it's a constant times x raised to some number. So you have this variable raised to a power, so that's a monomial. The coefficient of this monomial is the number. So in this case, it's 17. The degree, okay, where does it say? The degree is the sum of the powers of the variables. So well, in this case, there's one variable, x, and the power is 2, so the degree is 2. The degree of 17x squared is 2. Let's look at the next example, x times y. The coefficient is the number, so I have two variables, x and y, those are being multiplied. The coefficient is the number in front. Well, I don't see a number, but what's going on? It's 1 times xy. So the coefficient is 1. And what's the degree of this monomial? Remember, it's the sum of the powers of the variables. X times y is x to the first power times y to the first power. So I take those powers, I add them, 1 plus 1, I get 2. So this is also a degree 2 monomial. Let's look at the next example, negative 8x cubed times y times z squared. So I have the variables x cubed y z squared, right? Those are my variables, and then what's the constant that's being multiplied? Negative 8. So my coefficient, the coefficient of this monomial is negative 8. What's the degree? So for the degree, I'm looking at the powers, right? I'm looking at the exponents. I have x cubed times y to the first power times z squared, and 3, I add the exponents, 3 plus 1 plus 2, 3 plus 1 plus 2 is 6. So the degree is 6. Notice that the degree doesn't depend on what the coefficient is. So if I change the negative 8 to like a billion, the degree would still be 6, right? If I just kept everything the same, but then turned the negative 8 to a billion, the degree would still be 6 because I'm still just taking the 3, 1, and 2 and adding them. Okay. So those are monomials, coefficients, and degrees. Here's an example of something that's not a monomial. Two over x. How come this is not a monomial? The reason why it's not a monomial is that you have a variable in the denominator. So you don't have x raised to a positive integer power. So well, yeah, you need, well, when I'm saying a variable raised to the power, we're talking about positive integers. So if you know about negative powers, 2 divided by x can be rewritten as 2 times x to the negative first power, but this minus 1 is not a positive integer. That's why it doesn't count as a monomial. Okay. But you can have a constant like 4. Okay, 4 is a monomial. So first example, second example, third example, fourth example. 4 is a monomial, its coefficient is 4, and the degree is 0. One way to remember this might be to rewrite 4 as 4 times x to the 0 power. So then the degree is 0. That's another way of thinking about it. Another way to think about it is just when you have a constant, the degree is defined to be 0. Okay. So two monomials are called like if they are equal or if only their coefficients differ. So when you have 9xy squared, negative 3y squared x, and xy squared, these are similar or like. So another word for like monomials is similar. Now how come these are like? Because if you look at the variables, you have an x times y squared in all of them. Notice in the second one it's written as y squared x, but that's the same as x times y squared. Okay. And let's make sure we remember the coefficients. They're 9, negative 3, and 1. On the other hand, if you had 5a squared b cubed and 4a cubed b squared, those are not like. Because even though you have an a and a b, in both of them, the powers don't match. So, in the first one, a is raised to the second power. In the other one, it's a raised to the third power, right? Those are not the same. So they are not like. Yeah. Okay, so a polynomial. So that was monomials. Now we're going to move on to polynomials. And polynomials, mono means one, poly means many. Polynomial. Polynomial is a monomial or a sum of monomials. Okay, we're going to define some more terms and then we'll do some examples. Each monomial forming the polynomial is called a term of the polynomial. A polynomial is in simplest form when it contains no like terms. The degree of a polynomial is the greatest of the degrees of its terms when it's written in simplest form. Okay, so let's just look at examples to see what that means. So I have a bunch of examples. So for the first one, a cubed minus 2, how many terms do I have? Well, how many things are being added or subtracted? That's what the question is asking. And when I look at a cubed minus 2, I see that I have one term which is a cubed and another term which is, well, it's a cubed minus 2. We remember that we can write that as a cubed plus negative 2. So since those are the things that are actually being added, the terms are a cubed and negative 2. So just want to erase this. Oops. Okay. So I have 2 terms in the first example, and the degree of the polynomial is 3. Because the first term has degree 3, a cubed has degree 3, negative 2 has degree 0. And by definition, the degree of a polynomial is the greatest of the degrees of its terms. So I have a degree 3, degree 0. 3 is the biggest of 3 and 0, right? So that's why the polynomial has degree 3. Okay, let's do another example. So 4a squared b. How many terms do I have? I have 1. Why do I have 1? Because I'm not adding, I have a 4a squared b and I'm not adding anything to it, right? So the 4a squared b I'm thinking as like one thing. That's one term. So that's why the number of terms is 1. For the degree of the polynomial, well, I only have 1 term. So I'm looking at this is a monomial. And so the degree is 2 plus 1, which is 3. Again, because I have an a squared, that's 2, and then b to the first power, that's 1. 2 plus 1 is 3. Okay, the next one is also a monomial. Negative 6 is a monomial. That has 1 term, and the degree is 0. What about the next one? X squared plus 3xy plus 4y squared. How many terms do I have? 3, right? The terms are x squared, 3xy, and 4y squared. And what's the degree of this polynomial? It's not a monomial, it's a polynomial. The degree of x squared is 2, the degree of 3xy is 2, the degree of 4y squared is also 2, so the maximum of those is 2. So the degree is 2. What about 12x to the 5th power minus 7x to the 4th power minus 8x cubed plus 9? Well, I can see by counting that I have 4 terms. And what's the degree? 5. Because I look at the degree of each term. The first term has degree 5, the second term has degree 4, the third term has degree 3, the last term has degree 0. Out of 5, 4, 3, and 0, the biggest of those is 5. So that polynomial has degree 5. Let's do one more. So this one has multiple variables. How many terms do I have? I count them, I count 6. And what's the degree? It's 5. It's from this term, this 4yz to the 4th term. That has degree 5, and then everything else has degree 5 or below. So the degree of this polynomial is 5. So there's no way to tell right away what the degree of a polynomial is. You have to look at each of the terms, find the degrees of each of those, and then look at what is the biggest degree out of all of those. Okay, and then a few more terms that are sometimes used. A polynomial that has 2 terms is called a binomial. So one example is x squared minus 5x. And a polynomial with 3 terms is called a trinomial. So for instance, a to the 10th power plus 3a squared plus a. So I have 3 terms because I'm adding that, and that. Those are my 3 terms. I wouldn't bother memorizing the terminology, binomial and trinomial, but they are terms that show up occasionally. Okay, so that's the terminology of monomials and polynomials. Let's go on to adding and subtracting polynomials. Well, when we're thinking about polynomials, these variables, we're thinking of them as placeholders for numbers, right? We're thinking of x as like a number, but we just don't know what the number is, so we just call it x. So the way variables work when we're talking about adding and subtracting, they work the same as any other number. Okay. So the sum of two polynomials is the polynomial obtained by removing parentheses and combining like terms. In other words, you just add the terms together. So for the first example, 3x plus 6y minus 8z, so I'm taking this polynomial and then adding it to the polynomial 2x minus 9y plus 3z. Well, I just add the terms together. So let's get rid of the parentheses. So 3x plus 6y minus 8z plus 2x minus 9y plus 3z. And now I am going to rearrange the terms. Remember, when you add, it doesn't matter which way you add them, right? That's the commutativity property of addition. So I see that I have a variable x, and what I'm going to do is I'm going to look at all the terms that have an x in it. So in this case, it's 3x, and I have a 2x. And I can add those. 3x plus 2x. Well, I'm not going to add them yet. I'm just grouping the x terms together. Let's group the terms with a y. Well, I have a 6y and a negative 9y. Now make sure you're paying attention to the minus sign, because it's a plus negative 9y. So I have a 6y minus 9y. And then finally, I have the z terms. I have negative 8z and 3z. So I'm going to put that there as well. I'm just going to write minus 8z. If you want, you can put plus negative 8z, if that helps. Okay, now I'm just going to add them. 3x plus 2x is 5x. 6y minus 9y is negative 3y. Negative 8z plus 3z is negative 5z. So I have 5x minus 3y minus 5z. That's what I get by adding. For convenience, we sometimes arrange the work vertically. So what I did was fine, but sometimes you might find it easier to rewrite it like this. So I take 3x plus 6y minus 8z. That was my first polynomial. And now I'm adding 2x minus 9y plus 3z. And since I'm adding them like this. And when I write it like this, I just add vertically. So 3x plus 2x is 5x. 6y minus 9y is negative 3y. Negative 8z plus 3z is negative 5z. You see how much easier that was? I mean, it's the same process. It's just a lot faster when you write it like this. All right, next example. Well, I am going to add them vertically. So write vertically and then lining up the like terms, so that way I can just add down vertically. So it's 3a minus 10b minus 9c, and then I have a 2a and a minus 2c, and I'm going to put the minus 2c below the minus 9c so that I have a column for the a, a column for the b, and a column for the c. It might be easier to write it as 2a plus 0b, because that's really what I have, a plus 0b. Okay, just to have something in that entry. And then the last term is 2a plus 4b, a plus 0c. And now I just add them down. So 3a plus 2a plus 2a is 7a. Negative 10b plus 0b plus 4b is negative 6b. negative 9c minus 2c plus 0c is negative 11c. So it's 7a minus 6b minus 11c. Okay, let's do another one. So for this one, we could also just add them vertically. So 4x cubed minus 2x squared y plus 7y squared. And then I'm adding 8x cubed. So I'm going to put the 8x cubed below the 4x cubed. And then I have a plus 3xy squared. Well, notice that when you look at the terms in the first polynomial, there is no xy squared. There's an x squared y, but that's not the same as xy squared. So what I need to do, if I'm going to do this, is I need to have a separate column for the xy squared. So 3xy squared. And then minus 3y squared, well, I have a 7y squared above, so I'm going to put this here. And then I have to put a plus to make sure we understand that we're adding them all. Right? So now we are just adding the terms together. So 4 plus 8 is 12, 12x cubed. And then for the x squared y, I have negative 2x squared y. And then I have 7y squared minus 3y squared, that's 4y squared. And then I have a plus 3xy squared. Again, if you wanted to, you could also fill it in like this, plus 0xy squared, plus 0x squared y. You don't have to, but it might be helpful. Okay, so now that's adding polynomials. Now let's talk about subtracting polynomials. Well, it's pretty much the same as how you would subtract numbers. Because remember, when you're subtracting something, that's the same as adding the opposite. So if you subtract 5, it's the same as adding negative 5. Similarly, if you are subtracting x, it's the same as adding negative x. If you're subtracting y, it's the same as adding negative y, and so on. So let's look at an example. Simplify 12a minus 3b plus 4c minus parentheses 7a plus b minus 2c. Okay, so we are subtracting this whole polynomial 7a plus b minus 2c. So let's write the problem vertically like this. 12a minus 3b plus 4c minus parentheses 7a plus b minus 2c. Notice that I'm lining up the a's, b's, and c's. Now we change the signs and add. So remember, when it's minus 7a plus b minus 2c, we're subtracting 7a, and then subtracting b, and then subtracting negative 2c. So I'm adding negative 7a, and I'm adding negative b, and I'm adding 2c. And now I'm just adding like before. 12a plus negative 7a is 5a, negative 3b plus negative b is negative 4b, 4c plus 2c is 6c. So my answer is 5a minus 4b plus 6c. Now we could also have subtracted across and then done the problem horizontally, and I'll do that for this last example. So for this one, I'm taking 2x minus 3y, subtracting 4y plus 7x, and then subtracting 3x minus 8y. So first, I'm going to turn all of that into an addition. So it's 2x minus 3y, and then minus 4y, minus parentheses 4y plus 7x. That's the same as subtracting 4y and then subtracting 7x. And then I have a minus parentheses 3x minus 8y. That's the same as subtracting 3x, so minus 3x, and then I have a minus negative 8y, that's plus 8y. Now I'm going to combine the terms together. So I have the x terms, right? I have a 2x, and then I look at each term, where do I see the x's? I have an x there, I have an x there. So it's 2x minus 7x minus 3x. Now I look for the terms with the y's. So I have a y there, a y there, and a y there. So I'm going to get minus 3y minus 4y plus 8y. So now I can put the x and y terms. Well, I'm going to combine the x terms and then combine the y terms. 2x minus 7x minus 3x is, well, 2 minus 7 minus 3 is negative 8, so negative 8x. And then negative 3 minus 4 plus 8 is 1, so I have a plus 1x, plus 1y. So it's negative 8x plus y. Let's just maybe remind ourselves of how that works. So when I have something like 2x minus 7x minus 3x, the step I'm sort of skipping is I'm using the distributive property to write it as 2 minus 7 minus 3 in parentheses times x. That's from the distributive property. And then 2 minus 7 minus 3 is negative 8. Just in case it wasn't clear what I was, why you're allowed to just combine the coefficients together. So what we did in this video is we went over some of the vocabulary about polynomials, so monomials, coefficient, degree, okay, what like terms are, and then polynomial is just a bunch of monomials added together, the degree of a polynomial, and then how to add and subtract polynomials.